Now, in any big unit of quadratics, a large part of it is going to be spent trying to find the roots of a standard form graph, okay, or the x-intercepts. Okay, that is because it is one problem that's not immediately obvious from these constants a, b, and c. Okay, for example, y-intercept is just at 0, c. But the x-intercepts, the roots, are not as obvious. Okay, you have a quadratic formula, but there's one other major method. Okay, and the reason that it's tricky is because the x-intercept is when y equals 0, so you can set y equal to 0, but what you find when you try to solve it using regular methods is that you can't really very easily. Okay, you could try moving over this c, but then you have an x squared and an x, and you kind of get stuck. Okay, so in solving this problem, you're also giving yourself a method for solving any quadratic equal to 0. Okay, even if it's not in a situation where you have a graph. Okay, so if you have anything with x squareds and x's in it, okay, on either side, okay, this can be rearranged to look like this, and therefore this is an important problem to be able to solve. Okay, now what we do to solve this, or one method at least, is we can look to the factored form of quadratics. The reason for that is that we can find the roots of a factored form equation very easily, okay, because again we're going to set y equal to 0, okay, because the y coordinate of any x-intercept is 0, and here I actually have three things multiplied together, and if I make any one of them 0, then immediately the whole thing does equal 0 as desired. Okay, if I make p equals 0, if I make x equals p, then this left-hand side bracket will equal 0 and the whole thing equals 0. Same thing if I have q here. Okay, so setting the x-coordinate as p or q will solve this equation. Hence what I've written down here, that the x-intercepts are found at p0 or q0. Okay, and, well, we've just seen a solution to a quadratic. So the goal now is, can we change ax squared plus bx plus c to something that looks like this, something in factored form, i.e., can we factor a quadratic? Well, to do this, a good idea is to start with the opposite. Okay, if we have a go at expanding, okay, and make sure you expand it properly. If we expand, we begin with 4 terms, and then we can combine to just 3. Okay, and I've gone from factored to standard form. We'll look at where those numbers came from in a second. If I expand this, and then simplify, I'm just going to write 1x now for clarity. I have this another standard form quadratic. Okay, but if you took a few seconds to try and find a link between these two numbers and the numbers found in the brackets, well, you can actually see from how you calculated this in the first place where it came from. Okay, this was minus 2 times 5. This was 3 times minus 4. Then the x term might not be so simple because it came from a combination of 2 terms. Okay, but that combination was minus 2 and 5, which are exactly the numbers you find here. So 3 itself is minus 2 plus 5. Minus 1 itself is plus 3 minus 4. Okay, so if we go back to calling this P and Q, well, it looks like the constant in the middle, the coefficient of x, needs to equal P plus Q, and the number at the end, your C, your constant, needs to be P times Q. Okay, so that should be simple enough. If we then want to go in the complete opposite direction, from standard to factored form, as I said we were going to try to do up here, then that's what we need to do. We need to find a P and a Q to put into here, to put into our brackets, that add to get our B and multiply to get C. So here's an example. If I want to find the roots of this equation here, I need to find two numbers that add to get 2 and multiply to get negative 24. Okay, so I can look at the multiplication first. Okay, maybe I could have minus 8 and 3, minus 12 and 2. I could go through a few of those pairs, and eventually I would find that 6 and negative 4 would be the ones, the P and the Q that I'm looking for. Okay, and you could expand it again just to double check, but that is correct. Now, if I want to make this equal to 0, okay, I make y equals 0 to find the roots, the x-intercepts, then all I need here is a value for x that makes the left-hand side bracket equal 0, and then the same for the right. So x equals negative 6 and 4. Okay, and those are the roots. Okay, what if it's not phrased as a graph question? Okay, just a regular equation equal to 0. Well, same thing. I need to find two numbers that multiply to get negative 72 and add to get, what's this? This is negative 1, essentially. Okay, and you could go through your options, 12 and 6, 18 and 4, well, various combinations of plus and minus, but you would eventually settle on negative 8 and positive, negative 9 and positive 8. And, well, this has already been set equal to 0, so we have the same situation with making either the left bracket or the right bracket equal 0 by choosing an appropriate value for x, and those values here would be 9 and negative 8. Okay, so this topic goes a lot further, especially when you start adding in a number here or here. You can also look into how many roots or whether it's possible to factor a quadratic, but this is the basis for the rest of your factoring and solving by factoring and finding roots by factoring. Okay.